We're going to evaluate the definite integral. Take the antiderivative of the x cubed. We know to take the antiderivative of that, we're going to add 1 to the power. Take the reciprocal of that power, bump it down to the front. Now that's the antiderivative portion of the function. The thing about these problems, since it's a definite integral, is you have to acknowledge your interval still. So we use a little symbol over here, a little bar, saying, all right, I still have to play with that interval. So there's that interval still represented for me to use. Since you've taken the antiderivative, according to the first fundamental theorem, all we got to do is plug in our a's and our b's, right? Plug in our b here, plug in our a there, take the difference. So if I plug in my b, that would be where the interval ends at 1. I plug in for x, I get 1/4 times 1 to the 4th. Whatever that is, I'm going to subtract. I'm going to take -2 now, plug in for x, be 1/4 times -2, 4th. That's applying the first fundamental theorem. If we do that calculation, we've got our exact area beneath the curve x cubed on the interval from -2 to 1. So the question is, what's that calculation? I'd say either of those answers are acceptable. You know, the first objective is taking the antiderivative, so how are we going to get started with that process? All right, we got that square root down here, so we got to do something with that root. Right? Raise the root, bring it up, negate the exponent, stuff like that. So at this point, we haven't taken the antiderivative. We're just simplifying the function that we need to take the antiderivative of. So this is x to the 1/2. We bring it up. It's x to the -1/2. Got a quantity of x squared plus 1 on top that we need to appreciate. Excuse me. We're going to multiply this through. So if we distribute, once again, have not taken the antiderivative yet, so all the integral symbols stay. Distribute, you got to add your exponents because of the like bases. So -1/2 and 2, that's going to be 3/2. Got x to the -1/2 times 1. That's pretty straightforward. There's a simplified function we can take the antiderivative of. So now we're in antiderivative mode. Add 1 to your power here on this first term. We're going to get x to the 5/2. Reciprocal at 2/5 to the front. Plus, add 1 to -1/2 on the second term. We're going to have x to the 1/2 there. Reciprocal is 2. That goes to the front. We've taken the antiderivative. We have not acknowledged the interval yet. So with respect to the interval, we put our notation in. And now we're ready to apply the theorem, which states I can just take this 2 right here, place those x's, that's what I get when I plug in 2 to that antiderivative. And then I can take 1, substitute in for those x's, and subtract from that first part. Now, if you plug in 1 for these x's, it's going to be 1 to some power, which is going to be 1. Meaning you've got 2/5 there times 1 plus 2 times 1, right? So I could say 2/5 plus 2 or 2 2/5, either way. The thing is, after you plug in all that stuff and you calculate it out, what do you get? What we get would be the exact area beneath this curve on that interval. What do we come up with there? Never a doubt. Never a doubt. It's 2.69, right? And then taking the antiderivative here, not too complicated, right? Your function is sine of x, so what's the antiderivative of the sine of x? Is it cosine of x or negative cosine of x? Well, if we take the derivative of cosine, that would be negative sine. That's not what we have over here, so it needs to be negative cosine of x. All right, negative cosine of x is the antiderivative for sine of x. We still have to acknowledge the interval we're working with. And now if we apply that first fundamental theorem, we take our pi over 3, we plug in, got negative cosine of pi over 3, minus, we take our pi over 4, plug in, negative cosine of pi over 4. Calculate that out, we got our exact area beneath that sine curve on that interval. I would say that that works for me. First objective, take the antiderivative. Got to use some u substitution, it looks like here, but what might you do before you even go down that road? Bump it up. So we are rewriting this rational function as x times the quantity x squared minus 1 raised to the negative second power. So we can more easily see how to substitute for what u is going to be. U is going to be the x squared minus 1. So we introduce the new variable, we set up the new problem. I'm going to leave this interval alone for just a second. I'll show you why after we do all our substituting here. But if this is going to be u is being raised to the negative second power, right? Meaning we still have to replace x and dx. So we go back over here to our u equation, we take our derivative. du equals 2x dx. Try and replace x and dx, divide 2 over. Apparently x dx equals 1/2 du. So insert 1/2 du. All right, now back to what the interval was. This is important. You've changed the variable, creating this new problem. The original interval, whether I look at these values or these values, right, they're all the same. This was all in terms of x. But now my problem's in terms of u. So you have to take the old x values that represent that interval, go to your u equation here, plug in those x values so you can figure out what the u values are for the interval. So take 2, plug in, 2 squared, 4, minus 1, 3. Interval on my new problem starts at 3. Take 4, plug in, 4 squared, 16, minus 1, 15. For my new problem, the interval ends at 15. Now everything, including the interval, is in terms of u. Meaning if you take the antiderivative of this, apply your interval, you're going to have your answer. So antiderivative of this, add 1, get u to the negative first. Reciprocal of negative 1 is negative 1, so multiply that to the 1/2 in front. Negative 1/2 u to the negative 1 is the antiderivative. Still have to acknowledge this interval. Now we plug in, got negative 1/2. U gets replaced with 15. And there's our first part when we plug in 15. Now subtract, plug in 3 for u. Do that calculation, arrive at answer. What's our answer here? All right, so 0.13 repeating.